Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
Good evening, everybody. And tonight, I'm still having a little problem with my camera, so unfortunately, I'm using some backup equipment. But there's a comet, we believe it's a comet, called 3I Atlas. Now, I've done complete shows on this before, so I suggest you go back and look at those. They're as valid today as they were when they were made a number of weeks ago. But there's so much misinformation coming out about this comet. They're saying, oh, it's alien, or it's an alien spacecraft, or some professor from Harvard is saying it's so unusual, it couldn't be natural, and just on and on. The craziness, let's just put it that way, is abounding. But one thing I can say in general is that everybody, the YouTube Looney Tuners, the Harvard professors, the people at NASA, the people who, the woo-woo NASA people who have YouTube channels, the pretend physicists that are on the internet, and the list just goes on. They all believe in the dirty snowball comet model. And clearly, if you've been following my work for more than a New York second, you realize that comets are not dirty snowballs at all. And so anyway, what I want to do tonight is go through some of the things that are known about this comet and what it's doing, and relate it to reality, the plasma discharge comet model. And of course, behind me, and pretty much a lot of my shows, I have this poster behind me. This was the 30-year poster, which is now 20 years old. So we're talking basically 50 years of my presenting the plasma discharge comet model to the scientific community. And they are so brain dead, they're so stuck on this dirty snowball comet model. And once people get let's just be honest, once people get a PhD, their brain there's some kind of a PhD switch. It turns off. The brain just doesn't work anymore. It doesn't, it's not active. It's locked into the concept of, oh, they're so smart, everything they know is true. And in the world of astrophysics, astronomy, and space science, what they've really learned is a lot of really wrong information. Let's just put it that way. From the Big Bang to the dirty snowball comet model to the evolution of you and me from nothing. Everything popped out of nothing. All of the organization you see in the universe is from random activity. Just, anything to deny the concept that there was a creator. So I'm not going to go down that road tonight, but you know the story. And so literally anybody that's talking about this comet, 3I Atlas is its name. It has an official designation, but very few people know what it is. 3I Atlas, it's the third, the name means the following. 3 is the third intergalactic object, interstellar, in other words, coming from outside of our solar system. And actually, I'll go into this a little bit tonight too, that just about everything that comes into the solar system is from someplace else and not related to our solar system. There is no such thing as the Oort cloud. But anyway, back to 3I Atlas, the name 3 indicates the third object that's coming in at very high velocity. And what's clear is these things happen all the time. It's just that we've never had equipment before that was able to resolve to capture these objects that are going so fast through the solar system. And so now we do have good equipment that can detect these objects. And so this is the third one, thus the number 3. I is indicative of interstellar, I. / Atlas. Atlas is the automated telescopic search engine that searches the sky for anything and everything. And there are more and more of these telescopes, amazing ground-based telescopes. Of course, we have the James Webb telescope that does specific, it looks at specifically at objects, and we'll go into this, what the James Webb telescope has been seeing. The Hubble Space Telescope had its turn at looking at this object, and basically it's coming in at very high velocity. So anyway, 3I Atlas is the common name that you'll see on the internet. Okay, so it was discovered in July of this year, so recent, and immediately, of course, they could tell within a few hours of taking measurements, they could tell that this object was going to come near Mars, and this will occur on the October 2nd. And then its closest approach to the sun is going to occur on around the in the 20th, I think the 21st of October. And then later, early next year, actually, it's going to be passing by the planet Jupiter. And so, and I've given all these dates. I'm not going to go through all the dates and all of the, I might give some of the charts here again tonight just to refresh your memory. But what everybody is interpreting, what they're seeing, the data that's coming in, that there's an exaggerated amount of carbon dioxide and carbon-based oxygen molecules, carbon monoxide, carbon dioxide, relative to H2O water, the hydrogen-oxygen compound that is commonly found in comets. So the ratio is not the same as normal comets. And there are reasons for this, physical reasons based on the plasma discharge comet model. Okay, so if you assume that this comet is a dirty snowball in outgassing, then you're assuming that this material is coming from the nucleus and being outgassed into outer space, and that's what people are measuring. Now, at first, the first kind of oddity of this so-called comet, and yes, it does have all the properties of a standard comet, it's just moving very fast. And so the first thing was that it was not developing a coma. Well, gee, here's what's going on. The object was moving so fast, and the plasma discharge comet model explains that the electrical discharge that's associated with this object, there's a space charge sheath around the object that builds up due to the electron current coming from the sunward side. And yes, they did determine a sunward spike. Very first thing, before this thing had a coma, anything else, they could see the sunward spike from this, and it continues to have a sunward spike, which they don't like to talk about because comets are not supposed to have sunward spikes, but this one did. And so what's going on is this thing is moving so fast. In a typical comet, there is time for the nucleus to draw in the ionized material, the water, and these are built, by the way, these molecules are built as they come into the comet nucleus. And you can see above me here, this drawing here is an example of a comet. That was actually a paper that I wrote in relative to a comet named Giacobini-Zinner, a small comet that was actually visited by a NASA satellite, the very first comet ever to be visited by a satellite. The comet was called Giacobini-Zinner, discovered by two astronomers. And then the ISEE-3 satellite was renamed ICE-3, and I was familiar with the physicists on that project. They were from Los Alamos. This is back in the 1980s. And this was at the time when last week's show, if you watched it, I did a reproduction of the talk I gave at Los Alamos during this time frame when this satellite came in. And these physicists worked at Los Alamos. So they were interested in my work and my interpretation of the reality of this comet relative to the plasma discharge comet model, not the dirty snowball comet model. Okay, so at any rate, the comet, typical comet, draws in material and forms a visible coma. This is the cloud of material, and typically it stretches in the anti-sunward direction, away from the sun, and that's because this object is drawing it in from behind, and that's due to the electric field. And you can see in this picture here, you can see the electric field as it spreads out, and it's a combination electric field of the sun and the charged comet nucleus. They actually, like I say, the space charge around the comet nucleus. Okay, so what's going on with a normal comet is there is time. The nucleus is not moving that fast, so it actually can draw in material, and this material can be drawn in and around the comet nucleus. But 3I Atlas was moving so fast that there was no time for the material to come in. It would see a fast moving object, feel the attraction, the electrical forces, and but it would be gone. It will be gone by. And so trying to hit a moving target that's going that fast, it really never formed a tail originally. And so what the dirty snowball comet model scientists were saying was, oh, this is so unusual, it's not forming a tail. And imagining that the material should be coming off the comet and forming the tail, which is not the case at all. And so this object was acting exactly the way it should have acted based on the plasma discharge comet model. Now, I should add, too, that there's some yo-yos out there trying to talk about electricity and comets, but they don't know anything about it. And what's going on, too, is a lot of these people are related to NASA. These are kind of NASA mouthpieces, and I won't go into detail, but there's a plethora of YouTube channels out there that have they're highly supported by NASA. Let's just put it that way, and they try and blend in electricity and comets, but they still harbor this dirty snowball comet model. So they're trying to be on both sides of the fence. Let's just put it the way it is. Okay. So anyway, the very first oddity of this comet 3I Atlas is not an oddity at all. The idea that it would not form a tail originally is exactly what should have happened. Eventually, the material and the charging on this comet became sufficient that it would draw in from a very large area, and that's where it is today. It's forming a very large coma. And this is the space charged sheath that forms around a comet. And if look at the video last week, I actually show a little kind of in laboratory experiment showing how the space charged sheath forms around a comet nucleus. And as it moves, like I say, it's the combined electric field of the comet nucleus and the sun, which gives the shape of the comet tail. And so anyway, okay, so that's the first oddity. Another oddity is they took a reflectivity spectrum of the comet nucleus, and they're saying there's really no coma, there's no gaseous coma around the nucleus. All we're seeing is reflected light. So they start to see nickel and iron, and in a balance, once again a proportion, that is not typical of what we see in the inner solar system. But nobody has ever measured the iron nickel content of planet Earth even. Remember that Earth has a lot of iron in it, a lot of iron and a lot of nickel. And what we detect is up very near the very surface, up in the mantle and in the crust. And a very, very thin, if you took a globe this size of planet Earth, the upper crust and mantle would be thin as a piece of printer paper. That's how thin the crust is. We have holes in that crust where the hundreds, thousands, literally thousands of volcanoes are erupting through that crust. That's how close we are to the magma, the liquid part of Earth. But believe me, nobody has ever drilled or gotten in close to the magma. There's no drill bit that could handle the heat. It would melt. It would turn into liquid goo. And so nobody knows the iron-nickel ratio of planet Earth even. You could guess at it. You could take a rock on planet Earth up on the surface, but it has nothing to do with the core. So for people to say that this has an unusual iron-to-nickel ratio is, bizarre. Who? The stuff that comes out of the scientific world is, just nuts. They have no basis for what they're saying. And so also the carbon and the carbon-oxygen and the hydrogen-oxygen compound ratios, they typically find these in comets, but they relate it to the comet nucleus itself. What it's really related to is that the mass of these various compounds. Now let me go through the physics of what happens in a comet. You don't have water and you don't have carbon dioxide, carbon monoxide in free space. What you have is oxygen, you have carbon, you have hydrogen, free in outer space. And so what happens as the comet nucleus, as these objects, a lot of them are ionized because space is a plasma environment, and the light from the sun, the ultraviolet light from the sun, hits them, and there's a constant process going on of ionization and then recombination of the charge, the free electron charge with the atoms, so that they're neutral again. When that brief moment when they are charged positively, they have a positive charge on them, that's when they're drawn in, and these are the atoms, carbon, oxygen, hydrogen, and oxygen might be in molecular form, which is also possible, and but it's in a basically atomic form. So when these come in, they're drawn into the comet nucleus. They're coming in at pretty high velocity. If this comet is moving at 60 kilometers per second or whatever it is, very fast. Then the ions coming into, following those electric field lines, are coming even faster. So when they collide, they combine. And so it's the combination of those, and they readily combine, carbon and oxygen, CO2, CO, hydrogen and oxygen, and then you have the hydrogen-carbon compounds, which we call oil. So that whole series of carbon-hydrogen compounds, what the ancients called naphtha, when the Earth would pass through a comet tail, there would be the meteor streams, and then what the ancients called naphtha. And then, of course, there would be water coming in the atmosphere. The Noah's flood was Earth passing through the tail of a large comet for the estimated 40 days and 40 nights. And remember that 40 in the Bible is a figurative term. There's 40 days Christ spent in the desert, 40 days and 40 nights of torrential rain, Noah's flood. And 40 comes up all over the place in the Bible. And that was, in the ancient times, a number so big that nobody could comprehend it. Remember, these people had trouble counting to 10. And, some people couldn't even count to 10. They didn't understand the number 10. Number of hands is, fingers on your hands back in those days. Don't assume that people were quite as knowledgeable as you about counting to 10. Okay, so 40 was a big number. And so anyway, Noah's flood was Earth passing through the tail of a large comet for an undetermined amount of time. We say 40 days and 40 nights, but that's a figurative term. Okay, so what happens then is as these materials are drawn into the region around the comet nucleus, some of them, because there's an abundance of electrons around the comet nucleus, because there's the electron stream coming out from the sun. That's part of the electrical discharge. In any electrical discharge, the bulk charge carrier, because of the charge to mass ratio of electrons, is the bulk charge carrier is in the form of electrons. And they're coming out from the sunward side, because in the solar system capacitor, the sun is negatively charged relative to the nebular ion cloud out beyond Pluto, which is positively charged. And so so at any rate, these molecular forms, species that are formed coming into the comet nucleus, then could be neutralized, or if the object nucleus is large enough, then these chemicals, the carbon hydrogens, the carbon oxygens, the hydrogen oxygens, and there's other things that are like the, various forms of, water is the most common, H2O. But you have H2O2, you have the other variations of comet species in the coma, species of chemicals of hydrogen, oxygen, and a lot of H carbon, because they form readily also. Okay, and this is what you see in the comet tail. So for an object that's moving faster, you're not going to see the same carbon, oxygen, like carbon dioxide, carbon monoxide ratio as you would with a regular lower velocity comet. So once again, it's not due to the content of the nucleus. You see what I mean? And the dirty snowball, I'm going to call them idiots, because this idiocy has been going on for far too long. Decades and decades where it's very clear that comets are not dirty snowballs. The head of NASA, 2018, after the comet, P67, came through the solar system, and the European landed on the nucleus of the comet, no snow, no water, no ice, nothing coming off the nucleus, yet they still continue to call it a dirty snowball, saying, oh, well, that water's down deeper. Well, if the water's down deeper, it's got to be getting out of there to form the tail, right? I mean, we're talking about gross incompetence and stupidity in the standard scientific community. And all these YouTubers who follow along like little puppy dogs with a ring in their nose. Okay. So, at any rate, on the second count of this comet, it is doing exactly what you would expect it to do. It would not have the same ratio, and that goes, it would not have the same ratio of carbon monoxide to carbon dioxide as with a normal comet, because they react differently, because the charge to mass ratio of the species of materials that are coming in towards the comet nucleus. Okay, now it's forming a very large coma at this point, which is very interesting. And also you would expect that, because let's take the example of the backyard bug killer. And here you have a very similar situation in outer space. In outer space you have plasma charge, space charges due to the fusion reaction of the sun, which separates charge. There's an excess current of protons in the solar wind, and that happens around Jupiter. And that's going to affect this comet, by the way. I'll be talking about that in a minute. Jupiter has its own space charge sheath relative to caused by the proton wind that's coming off Jupiter. And that is not speculation. That was measured by Voyager 1 and 2 as these went by Jupiter and reported in the Nature and science journals. The journal Science is the American journal. Nature is the European equivalent of what you'd call a glossy, high-level, peer-reviewed journal. Reported by Brad Smith, the head of the Voyager program, reported directly that there was a proton wind measured coming off of the surface of Jupiter, and that's because of the fact that Jupiter is not a planet. It is a small unlit star, unlit in the visible spectrum. But take a look at Jupiter in the infrared, or or microwaves. It is hot. It is steaming hot, and it's around the edges where the bands meet, and in the regions like the Great Red Spot. Very hot, with a lot of lightning, a lot of fusion, and the separation of charge, which causes the proton wind. Okay, so this comet is going to come very near Jupiter, close enough where their space charge sheaths are going to combine. And wow, it's going to be a light show. I think we're going to see some major activity early next year when this comet comes by Jupiter. Okay, so let's go back to the current day. It's not going to be near Mars for another, October 2nd. So we got about a month to go relative to this comet approaching Mars. And so let me just take a segue here. Do I think that this is some kind of alien spacecraft coming in to monitor Earth or send off spacecraft that'll come around Earth, and that there's some kind of diabolical plan of aliens, that it's reaching its closest approach to the sun when Earth is on the other side of the sun? No, none of that. It's all hooey palooey, phony baloney. And the idea, this guy at Harvard, who's the first one off the block to start talking about this, I think he's going to take some credibility hits in the long run. Because, if you were an alien, it's probably not the path you would take into the solar system. But, the point I'm trying to make in my talk tonight is that this comet is doing exactly what a normal comet would do. Now, let me talk about the size of the nucleus. And I've talked about this before, but I'm going to go through it again because it's very important. When it was first discovered, the idea was that they thought it was bigger than normal. Now, a normal comet nucleus, like Halley's nucleus, is 7 kilometers, like a potato shape, but about 7 kilometers in the long direction. Or is it miles? I forget. But, it's a fairly big object the size of Manhattan, racing through space, and big enough when it discharges the solar capacitor to create a significant comet tail that we can see from planet Earth. The comet now, this 3I Atlas, has a coma that is large. It's on the scale of about, if you compared it to the coma of the comet, not the nucleus, the coma of the comet, it would be about 5 diameters of Jupiter. That gives you, so that's pretty big. That's pretty big. But remember, the cover of my book, Planet X, Comets, and Earth Changes, there's a diagram drawn by some ancient cave dweller on a cave wall. This was at Green Rivers, Utah, of a comet with a nucleus that was commensurate with the size of the coma. And it's very clearly marked that it's the nucleus. So we're talking about something there that's potentially Jupiter or larger in size, nucleus of a comet. And so, yes, they can be big. And this is something I've been emphatic about since my early work at the Cornell days, is that you could have comet nuclei that are planet size and grow. Now, this is the thing that I'll just finish a thought here. I was talking about a minute ago. When this material comes in, drawn in by electrical forces, then what happens is that if the object is large enough, it has enough gravity, surface gravity, that's the force of gravity at the surface of the object, to hold and maintain the material coming in from the tail, which means it's growing. Now, Comet Hale-Bopp grew extensively, and the one of the side effects, which tells you it was growing extensively, is that the orbit changed. The orbit went from a 4,200-year period orbit to a 2,600-year orbit. That's not quite in half, but pretty close to cutting its orbital period in half. That's the time it takes to go around the sun one time. And it did that because of what is known in my work as the tail drag. The tail drag is the literally as the nucleus of the comet pulls the material in, guess what? That tail is pulling back on the object, so it's like slowing it down. And the end effect of that, pulling back, that drag, the end effect of that is to circularize its orbit and cause that circular orbit to spiral inwards. We see this same effect in the Saturn's rings. I have a peer-reviewed published paper on this particular topic. When I was in the math department at Cornell, I wrote a paper predicting the moons in Saturn's rings, which were eventually discovered, known as sweeper moons. And they use the Saturn, once again, is like Jupiter. It's a small star. It has ongoing fusion in its atmosphere, therefore it has a capacitor, and therefore the rings being in that capacitor exhibit the properties of comets, and so do the moons. That's where the spokes in the moons come from, in Saturn's rings. It causes the inner moon ring edge to be slightly faded, whereas the outside edge of the moon, of the Saturn rings, are very sharply defined. That's because the nose side of the comet is very short and the tail side of the comet is very long. And so you see that effect in the fading of the edges of the Saturnian rings, and actually predicted this accurately before anybody ever was close to Saturn's rings to see these effects. Okay, so anyway, back to the comet. In the size of this comet 3I Atlas, the nucleus, and by the way, the comet nucleus of Hale-Bopp was large. It was planetary size, and NASA lied about it. And by the way, they use these observational techniques to measure the size of a comet nucleus, but they can easily directly measure the size of the comet nucleus using radio telescopes. But they do that, they actually make the measurement, but they don't announce it because these nuclei are much bigger than what they're supposed to be. Okay, but what they do is they use a measurement called albedo. Now, albedo is the reflectivity of the light. Now, like my forehead up here has a lot of reflectivity. It's almost 1. Whereas, let's say this black here, the same amount of light is hitting that as is hitting me. But reflectivity depends on the object. And so a dark blue object or a black object like these photos behind me absorb most of the light that hits them, and so they are considered dark. Whereas my forehead is light color, or this shirt a lot of reflectivity, and it turns out to be white. So this shirt is a good example of an albedo 1.0. All of the light that hits it is reflected back to you, whereas the albedo of this dark color up here is getting close to zero. It absorbs most of the light, does not reflect much back to you. Okay, that's the definition of albedo. How much light, incoming light, is reflected back. Okay, so on a comet nucleus, they assume is white, like snow. Like white in snow. They assume that it's white. Okay, so now you take your telescope, you look at the comet nucleus before it forms a coma, which was the case early on when it was discovered in early July of this year. You look at it with a telescope, there's nothing blocking it, and there's a certain amount of light that comes back to you. Now, if you assume that the surface of this object is white as snow and made of snow and ice, perfectly 1.0 albedo reflectivity, then, okay, you can calculate, because you know how much sunlight is reaching that, you can calculate how big the nucleus is. And they come up with 6 miles across. However, the nucleus of a comet, we know from all the comets we visited, are black. They're black, like these the sky in these black pictures here. The nucleus is black. So for a black surface to reflect that amount of light, like, by the way, our moon is black. You look at the moon and it's bright white. But that's the collective reflection of the entire surface of the moon. If you went to the moon and stood there, it would be so dark you could hardly see, even with the sunlight, even with full sunlight. And so that's because the surface is dark. Not because there's no sunlight, it's because the surface itself is dark, a dark gray color. Okay. So at any rate, if the surface of this object has very low albedo, which it does, then it's got to be much bigger. Get the idea? So there's 6 mile across estimate. Then they go, 6 to 50 miles. Wait a minute. 6 to 50 miles? That's like a 10 times difference, boys and girls. They're padding it. They're padding it because if anybody ever does come out with a real measurement using radio telescopes, then they would have like dirt all over their faces, egg on the face syndrome. So they give it a range, 6 to 50, and it comes out to be 5,000. Oh, we were close. These scientists are so lame. Just unbelievable. So it's very safe to say that the real measurement of the comet nucleus is big. It's like big, big, big. But potentially hundreds of miles across, potentially larger. The other thing is that to form a coma the size that is forming now, literally 5 times the diameter of Jupiter, it's got to be pretty big. And so also moving very quickly. Now, let me get back to the bug killer example. Excuse me, I'm sorry I'm losing my voice here. Hope I make it to the end of this show. But the bug killer example, let's take this as a physics example. Let's take 2 charged plates, one at ground potential, one at thousands of volts. And that's the case with the backyard bug killer. What happens? We've got a light in the middle, a fluorescent light that draws the bug in. Around that, you have 2 electrical grids, like screens, and big enough for the bug to fly through. The outside is grounded, so you don't kill yourself. The inside screen holds a high voltage, the charge. There's no real current moving here, it's just static charge. When the bug flies in, he crosses in through the grid potential of ground, flying towards the grid that has high voltage on it. And guess what? He discharges that capacitor, boom, right there. The bulk charge carrier in that discharge will be electrons. And so the bug is acting just like a comet. Now, what if the bug flies faster? Boom, it's going to be a bigger discharge, and it's going to be a faster reaction than if the bug flies through slowly. That's what's happening with this particular comet. So it's coming in at a very high rate of speed. And so the discharge of the solar capacitor for this comet, because it is moving so fast, is much stronger than for a regular comet that is moving slower. Let me go back. And in physics, a lot of times to give examples or to make a point, you use the extreme. So let's go to the extreme where a comet is not moving at all, hardly. Or like planet Earth. We're in a circular orbit around the sun, and it does not cross the gradient, the change in the electric field, which is radial. And so there's really not a big electrical discharge with planet Earth. We do have one. All of the planets are discharging the solar capacitor, but not very much, not like comets. Because comets are cutting in through the gradient of the electric field. They charge more than Earth. Take an object that's coming in at hypervelocity, and it's going to discharge that solar capacitor much more than the average comet, which is moving slower. So, the idea that this comet is forming a much larger coma is indicative of it moving faster. So once again, the physics of the plasma discharge comet model explain exactly what we're seeing. So do you have to warrant a alien spaceship bound from some other foreign star system? No. It is perfectly explained by standard physical principle. Now you see other people out there who are standard science apologists. I'll use that word. That's a nicer word than other words that I could use. But apologists, they're coming in and telling you all of the reasons why, this fits dirty snowball comet model. And so the problem is with the internet. The internet is so full of channels, and they're successful. Hundreds of thousands of people watching them, listening to them, which raises a point. If you like my content, hit subscribe and tell your friends. Put it on an email list and say, hey, if you want to know what's really going on, listen to this mechanic guy. But at any rate, I'm not big on promotion and all of that. I think this channel will grow generically and organically. But at any rate, back to the comet. So you have all of this misinformation about this comet. And what's the poor guy in the public supposed to believe? I mean, you're just being drenched, oozing with misinformation. And that's the whole point of misinformation. And so if you are a misinformation engine, like NASA, or like the intel agencies, etc., where they remember Casey, what was his name? I forget his first name, but Casey, the head of the CIA, 30 years ago, they asked him, when will you succeed as an agency? He said, when everything the American public believes is false, we will have succeeded. That's, it was Edgar, I forget his first name, but Casey was the last name, head of the CIA. And that's what's going on today. So what they do is they create both sides of the narrative. You got your NASA rah-rah YouTuber, you got your yo-yo YouTuber, a person that has absolutely no training of any kind, and then you've got NASA, and they're putting out their information. They got their defenders, their apologists, the Neil deGrasse Tysons, the Carl Sagans, or whoever, and the long litany of peer-reviewed published papers that come out of NASA when these observations are made, all saying the same thing, basically. What are you as a public, what are you supposed to believe? And the average person is not, believe me, is just not savvy enough to sort all of this out. And that's the point of this show. The entire point when this show started, and then my long-term radio show has been the same for 25 years. The James McCanny Science Hour at the Crossroads, 25 years and running. And the TV show now, well over a year into its existence, the whole point is to bring some reality to you, to the public. Okay, let's talk about where this comet is going now. Okay, so it's going to come by Mars in early October. Early October, the 2nd of October, I think, is the closest approach. And as I pointed out before, it has an oddly exact alignment with Mercury, Mars, the Sun, and this comet. Now, Mercury is what I call a spark plug in the plasma discharge comet model. It goes around the Sun very quickly, and a lot of times it acts as a spark plug when you have other electrical alignments. And in this case, it's like to the minute. And so you have this comet coming up and behind Mars, of which Earth is going to have a very good view on March 2nd. So, and I think the SOHO cameras, these cameras here that took these pictures, will have this comet in view. We'll have to see. I've not got a final reading on that yet, but there's going to be a lot of telescope activity looking at this comet. And believe me, what they're going to do is shut it all down, because this comet is going to interact with Mars big time. There's probably going to be hurricanes on Mars as a result of this comet passing by Mars. And not only hurricanes, but we'll probably have electrical discharge to the moons of Mars and to Mars itself. And so if Mars is bigger, Mars could gain a significant amount of atmosphere from this passage. And Mars, in fact, could go comet. In other words, the discharge from this passing comet could, in fact, cause Mars to literally begin discharging the solar capacitor. And we could see Mars as a large comet for a brief period of time, until Mars is in its circular orbit. It's not really discharging the solar capacitor much on its own, but when it interacts with this comet early October, there's going to be some things going on in the scientific community that believes that it's a little dirty snowball is going to be surprised. They're going to have to really dig deep into the rabbit's hat to pull out their excuses. Okay, so now, so that's the passage by Mars. And like I say, little Mercury is coming around. And what happens with that? You have an electrical alignment that will enhance the discharge between the comet and Mars. It's like I say, it's like a spark plug. And these are all factors. Now, when I wrote my weather book, the Principia Meteorologia, the Physics of Sun-Earth Weather, I talk about these trigger mechanisms, as I call them, and how they align. Like, for example, we've had situations where the new moon passing on planet Earth is a trigger mechanism combined with other alignments with other planets or Jupiter or other comets, etc., causing major weather on planet Earth. So Mars is going to see some significant activity, weather-wise, discharge-wise, and also remember my logo, which has the comet discharging to a planet. We very likely could see that exact shape and form, etc. And so anyway, the let's move on. Okay, after about 3 weeks after the close encounter with Mars, the comet by this point should probably be pretty big. It's going to be coming into its closest approach to the sun. And I think there, once again, this interaction with Mars is going to do nothing but build it up, make it bigger. And so we could see some significant activity there, including the ongoing sunward spike. So then now this comet, which is very much discharging the solar capacitor, probably very large, possibly could be visible to the naked eye on both would be the evening, no, it would be the morning sign at first, and then as it crosses behind the sun, it would be in the evening sky, and then it's going to move out to Jupiter, which is going to be very visible. And I showed all the alignments, etc., in the show a couple weeks ago that I did on this comet. But now, what's going to happen as the tail of the comet starts going out? The tail is literally part of the space charge sheath of the comet. And when that starts interacting with the space charge sheath of Jupiter, remember Jupiter has two types of interactions. One is its own proton-supported wind capacitor, and then it also is discharging the solar capacitor. Jupiter has one of the biggest electrical discharges of the solar capacitor in the whole solar system. And so this comet and Jupiter are going to start to interact. And you're going to see that difference in potential lighting up. And this is what the ancients talked about. The ancients talked about Jupiter throwing lightning bolts, and they actually saw it crossing to Mars. Okay, and so there again, Venus the comet was originally seen when it was captured by Jupiter and brought into the inner solar system, and then Venus the comet became this huge comet in the sky that lasted for literally hundreds of years as it slowly migrated in, the tail drag causing it to spiral in, eventually encountering Mars. According to the ancients, Mars had an orbit much closer to Earth. And Mars really took it on the chin. That had oceans, it had an atmosphere, and from what we understand, a human population. And so the whole funny business about Mars, now these little rovers, NASA up there, and they're taking pictures of craters, and Mars was recently covered with water and a significant atmosphere. And very likely was populated, and that's why there's a lot of secret activity on Mars with real serious research equipment that you will never see, and it's the same at the South Pole. There's a lot of archaeology going on at the South Pole, which is restricted. It is completely restricted from you, the public, from seeing this. Just a second, let me check excuse me, I'm just checking the timer here. It's got about 4 minutes left to go. So at any rate, Jupiter and this comet are going to have some serious interactions, and even interactions that may be visible to the naked eye. So you don't need your PhD NASA guy to tell you about it. Hopefully you will be able to see it, and then all of a sudden people are going to go, well, how's this little snowball interacting with Jupiter? You know, the Schumacher-Levy 9 was a very interesting comet. It broke into 21 pieces, and these individual pieces came into Jupiter. This is in like the mid-1990s when I was working with Russian scientists. They had trained all their equipment on this comet because they knew, due to my work, that comets were not dirty snowballs. NASA said, we're not even going to look at it. Didn't train a single instrument on it, although they deny that. They try and take credit for it now. In hindsight, they're always good at changing history. But they these pieces, as they came into the realm of Jupiter, turned into sulfur dioxide comets. That's because sulfur dioxide is the main chemical species in the region around Jupiter. That's why Io, the moon Io, is orangish color. That's why Jupiter itself is orangish colors, because of sulfur dioxide. And so these comets, all water comets, as soon as they get close to Jupiter, in fact, there's a picture on the cover of my book, Comets, which shows this very graphically. Okay, so I'll be talking more about this in future shows. We still have a couple weeks until this comet gets close to Mars, and then we're going to turn on the afterburners and really go after this story. In the meantime, a couple things here. Like I said, please subscribe to this channel. That'll improve the the activity on this, and send the channel information to your friends if you have a mailing list or whatever, to get this information to the public, because believe me, the rest of what you're getting on the internet, being polite, it's real garbage. A lot of copycats out there trying to act intelligent and really don't know what they're doing at all. Yeah, the whole plethora of garbage. And also remind you that my water filters, jmccwaterfilters.com, the MR5 whole house water filters are on sale. The lowest price we've ever actually had, $9.99 for a complete setup. The whole house water filter and the UV sterilizer package, called the Best Deal, is there. The gravity water filter elements, the replacement filter elements for your gravity water filter, and these are what we call the HI filter elements. They're simply the best on the planet, and they hang down into the lower container of your gravity unit, because those filters that are upwards in the upper container, guess what? When the water level drops down, top of that filter is not doing anything anymore, so all your water is being filtered through the bottom of the filter. Is a really bad design. Everybody else uses that design. I'm the only person that has filters that actually work, where 100% of the water goes through the filter 100% of the time. Okay, and then also my books. You'll find some of my books on Amazon. The list is growing. Just look for McCanny on Amazon and you'll find my books there. And then also on the webpage, JMCC, up here, the webpage, jmccsci.com. You can get to the water filter page, the book page, everything else from there. So once again, good evening, and we'll talk to you next week.
This has been Master of Science with host James McCanny. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern,